So hello, this is our screencast for correlation coefficient intuition. In this screencast, we are going to be estimating the correlation coefficient of various scatter plots. Prior to this correlation coefficient intuition lesson, you should have a good idea of positive and negative associations, and then we would use something like this when creating trend lines. Trend line is just another tool that we can use when looking at scatter plots. So let's take a look at what is the correlation coefficient. What is it? What does it do? And a correlation coefficient just describes the relationship between two variables, and it gives that relationship a number value. And specifically what we're going to be looking at today is, what about this linear relationship? Does our data lend itself towards looking like a straight line? Or does this graph kind of look like scattered all over the spot? So that's what this correlation, it's a number that we use to describe how close is this data to looking like a straight line. Now, the variable that we use is r. I'm pretty sure like in some Greek or Latin definition, there's a reason for the r. I'm thinking r stands for relationship. So that's the variable that we're going to be using when referring to the correlation coefficient. And then, as I said, we're going to use a number. This correlation coefficient is a number, and that number will always be between -1 and 1. So let's take a look. There's really, I guess 3 different cases when we're looking at these correlations. And one of them is when r is greater than 0. That's going to give us this positive linear correlation. So remember, let's for instance take a look at, like the sales of ice cream as the temperature gets hotter. Obviously as the temperature gets hotter, there will be more sales. And looking at this data, if we could draw that line that describes the data, that would definitely have a positive slope. So we would say that it has a positive correlation. This data looks kind of line-like, and the slope would be positive. So when your r is greater than 0, when your r is positive, that means that there's a positive linear correlation. Now, when your r is negative, that means that there's going to be a negative linear correlation. So if we're thinking about, do people want a hot hamburger when it's very, very warm out or very, very cold out? In this case, I guess they're saying that people, the hotter that it gets, the less people want hamburgers. And you can see that my data is still also very line-like. It's pretty close to that line, but in this case, the slope of that line is negative. So it has this negative correlation. As one of the values gets larger, the other value gets smaller. And that's what that negative linear correlation is looking like. Now, we also have when r is 0, and r is 0 would be no correlation. And you know how people like their coffee. Some people just like their coffee. It doesn't matter what the temperature is. So here we have something very scattered. We're not really able to draw a line through this data. There's no correlation between the temperature and people purchasing coffee. So that's just one way to think about this positive, negative, or no correlation. So let's get to another look, and let's see if we can make it even more intuitive. So here we have 2 graphs, and both of them have this positive correlation. As one value gets bigger, the other value gets bigger. As one value gets bigger, the other one gets bigger. But one of these looks more line-like. One of them has more of a linear pattern, and the other one is much more scattered. So there is a mathematical way to figure out what these correlations actually are. Like there's a way that people figured out that the correlation is 0.21 and 0.94. We don't really care about that. What we want you to do is, can you match them? Which of these looks more line-like? Well, I would think that this one looks more line-like, so it's probably going to have the correlation coefficient closer to 1. And the one that looks more scattered it's going to have that positive correlation that's closer to 0. So really when we're asking you, to estimate these, we're going to give you the correlations and we want you to just match them up. The one that is closer to 1, the correlation coefficient that's closer to this positive 1, that's this one looks closer to a straight line than the other one. Now let's take a look at another example here. Now both of these look like they have negative correlations. As one value gets larger, the other value is getting smaller. So both of these correlations are going to be negative. But now I need to kind of figure out, which one looks more line-like and which one looks a little bit more scattered. So again, as I'm looking at this one, I kind of see that there's a line. I definitely notice that it's negative, a negative correlation, but it doesn't exactly look like a straight line, at least not like the one next to it. This one definitely looks very line-like. So I'm going to guess that this one is negative 0.57 and that this one is negative 0.97. The negative just refers to, like, if you were going to draw a line, would its slope be positive or negative? And both of these have negative slopes. And then the number part of it is just relating, how close to a line does it look? And that pretty much is how we just go ahead and estimate the correlation coefficients for our scatter plots. And there's our screencast.